Alright, so today I'll be teaching you how to find the volume of an object using the shell method. And so, for example, I wrote a problem down right here, and usually what they'll do is they'll give you a bunch of lines, so like 3 lines, and they'll tell you where it will be rotated. It's usually along the x-axis or the y-axis, but for this example, we're going to be using the x-axis. And so if we were to draw this graph, it would look something like, actually, no, I'll just draw the whole thing. So it would look something like this. So x equals 0, x equals 4, 1, 2, 3, 4. Y equals x plus 1, something like this. Alright, so the graph is, I just roughly sketched the graph. And at this point, it's going to be, you're just going to have to picture the object in your head. And so if you rotate this around the x-axis, we know that the representative rectangle is going to be perpendicular to the x-axis. And so you have to write delta x. And so now you have to know where the intervals are. And to find the interval, all you have to do is, well, for this question, actually, they give you the intervals 0 and 4. But usually what you'll have to do is set the two equations equal to each other, and it'll give you the two intervals. But in this case, fortunately, we are given the intervals. So for the shell method, all we have to find is a volume. And so the equation of delta V is simply r squared delta x. And so, or pi r squared, or yeah, that's the equation. And so with that, we just have to plug in the information that we find. And so first of all, we would just hold on a second, I'm sorry. All right, so we're trying to look for r, and we know that r is equal to pretty much the height of the rectangle. And this line right here is x plus 1, and this right here is the height. And so with that, all we have to do is square the x plus, or r, which is x plus 1, and so I'll just rewrite it. So 0 to 4, x plus 1 squared, oh, and the pi, I forgot the pi, and then dx. And then from here, it's just simple integrals. And so, move that over. I'm just going to FOIL this out, actually. So x plus 1, x squared plus x. And so this is going to turn out to be x squared plus 2x plus 1 dx. And then you're going to find the antiderivative. So it's x cubed over 3 plus 2x squared over 2. Then it's just x. And then 4 pi. And I would just plug in the numbers, the 4. And so 4 minus, oh wait, no, it's 4 cubed over 3 minus 0 cubed over 3 plus 2 times 4 squared over 2 minus pretty much 0 over 2, honestly, plus 4. That'll be it. And once you, oh, sorry, this is out of the frame. Once you complete this equation, actually, you know what? I'll just do it right now. 64 over 3 plus 16. I keep forgetting the pi. The pi always comes down. All right. 16 to 32. 16 plus 4. And once you add them together, 64 over 3 times pi. Common denominator for 3, 64 over 3, 60 is 124 over 3 pi. And this right here, after all that integrating, that is your area of the frustum, or whatever it creates. It's like that. So, yeah.